Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Ilalaban kahit kanino, oo, simple lang ako at malabo mong magtipuhan. Kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka laging
Hello guys, this is Justin Bibilan, Organizon 118, and welcome to my YouTube channel. So, last episode we discussed about naming alkanes and also reactions of alkanes and cycloalkanes. So for today's lesson, we will move on to the next topic, which is actually about unsaturated hydrocarbons. So what are unsaturated hydrocarbons? So basically, for alkanes, they are called saturated hydrocarbons because they compose of carbon to carbon single bonds only. So for unsaturated hydrocarbons, we have alkenes, which contains the carbon to carbon double bonds, alkynes, which contains carbon to carbon triple bonds, and of course, the last one is the aromatic, which contains the benzene ring. So example of these compounds that contains unsaturated hydrocarbons are actually we have palmitoleic acid, which is actually a carboxylic acid. So we will discuss more on carboxylic acid later on when we talk about carbonyl groups and of course carboxylic acid groups. But in this case, a palmitoleic acid is also known as uh, monounsaturated fatty acid because it actually contains when say mono, that means one. It has one unsaturation, that means it has one carbon to carbon double bond, so it is a monounsaturated fats, or it's a monounsaturated fatty acid. So palmitoleic is actually used for it's actually found in in milk, in olive oils. So mostly fatty acids are actually in oils or olive oils, macadamia oils, and also in milk. Okay, so that is where you find palmitoleic acid, and there are also a lot of scientific evidences that palmitoleic acid are actually good for the health. And also, we have here the structure for the vitamin A, which is actually required for our vision. So this is the condensed formula for the vitamin A. So we go further for the line structure for the vitamin A. It actually contains a conjugated system on its structure. So when we say conjugated system, this is what we call an alternating of carbon to carbon double bond, single, double bond, single, double bond, single, and double bond single. So that is what we meant by conjugated system. And for conjugated system, uh, for alkenes, it's actually a very stable structure when there is a conjugation on its formula or in its compound or in its structure or on its system. So this is now the line structure for the vitamin A. And of course, this is the next one is the lipid soluble vitamin, which is actually the vitamin K, which is actually involved in blood clotting. So this is very important for blood clotting. So especially if you have wounds, open wounds, etc. So vitamin K is responsible for blood clotting. Okay, so we can see the structure for vitamin K. It has an aromatic ring, a benzene, and also an alkene, which is actually carbon to carbon double bonds. So it's very important that you will know about unsaturated hydrocarbons because mostly compounds, especially in our body, are actually composed of unsaturated hydrocarbons, and they are actually very good, uh, compounds that are actually present inside the living organisms. Okay, so first we're going to discuss is about alkenes and alkynes. Okay, so what are alkenes and alkynes? So generally, when we distinguish about alkene, and alkyne, so the general formula for alkane, so if you recall the general formula for alkane, that is actually CnH2n plus 2. Now for alkene, it is actually two fewer hydrogens compared to your alkane. So just like the formula for the cycloalkane. Okay, so the formula would now be CnH2n, and for alkyne is much lower, fewer hydrogen than your alkane. Okay, it has actually CnH2n minus 2. So for example, if you have ethane, so your ethane, the formula is C2H6, or the condensed or the structural would be CH3 and CH3. So that is C2H6 for 2 carbon. So you already knew about how to get the molecular formula. So for 2 carbon group in alkene, so you have C2H4, that is 2 times 2. You have N is equal to 2, so C2H2 times 2, that would be 4. So you have carbon to carbon double bond for alkene. So you will know that this compound is actually alkene if you can see a carbon to carbon double bond. Okay, so that is ethene. So the IUPAC name is ethene, while the common name is actually ethylene. Okay, then for alkyne, so if you have 2 carbon, that is C2H, 2 times 2 is 4 minus 2, that would be 2. So C2H2. So you will know that this compound is alkyne uh, if you can see on the structure that it is a carbon to carbon triple bond. Okay, so this is a compound that is also known as ethyne, which the common name is acetylene. Okay, so you notice that for alkane, it actually ends with ANE. Okay, for alkene, it actually ends with ENE. And for alkyne, it actually ends with YNE. So we will know later how do we name alkenes and alkynes. Okay, so molecular formula for ethane, that is C2H6, for ethane, that is C2H4, for acetylene or ethine, that is C2H2. Then we can also write the condensed formula for ethane, for ethene, and for ethine. So for alkene, for condensed formula for alkene, uh, you should actually draw it or show the carbon to carbon double bond, and for alkyne, you're gonna show the carbon to carbon triple bond. So basically, what are the properties? So how does alkenes and alkynes differ from alkanes? So the properties for these three hydrocarbons, for geometry, so we already knew that for alkanes, basically the geometry is tetrahedral. Now, for alkenes, it's actually planar. Okay, and for alkynes, it's actually linear. So the band angle for alkanes would be 109.5 degrees. For alkenes, that is 120 degrees. So it is planar. And for alkynes, it's actually linear. So that means the band angle should be 180 degrees. And all of these hydrocarbons, alkanes, alkenes, and alkynes, since they are all only contains carbon and hydrogen, are actually nonpolar. Since they are nonpolar, then they can be dissolved for nonpolar solvents, because the general rule for solubility, like dissolves like, correct? Okay, for boiling point and melting point, so we would expect that because they are hydrocarbons, so we would expect that they have also low boiling point and low melting point. But according to the molecular weight of that compound, so that the more it is actually has high or increasing in hydrocarbon chain, then the more it increase also in its boiling point and melting point. Just like your alkane. So I already discussed the melting point and the boiling point for alkanes. So increasing molecular weight will increase the density, and therefore will increase also the boiling point and the melting point. Just like also for alkenes and alkynes. Okay? So the next would be, how do we name alkenes or alkynes? So number one rule, so this is actually also the IUPAC system of nomenclature. So International Union of Pure and Applied Chemistry. Okay. So number one rule is name the parent compound using the longest continuous carbon chain containing the double bonds. So for alkenes, that is containing the double bonds, and for alkynes, that is actually containing the triple bonds. Okay, just like for naming alkanes, you should also distinguish or determine the parent compound which actually contains the longest continuous carbon chain. So like for example, so if you have two carbon on the continuous carbon chain, then that would be for ethane. That is for alkane. But uh, for alkene, so we should actually replace that three letter at the end, which is ene, and into ene for alkene. Okay, so that we would distinguish that this parent compound contains the double bond, which is an alkene. So therefore, that name would end into ene because it is an alkene. While if it is an alkyne, then the parent should end with yne. So for a two carbon compound, which is ethane for alkane, it becomes ethene if it is an alkene, then it becomes ethyne if it is an alkyne. Okay, just like also your propane. So if it is an alkane, then therefore it is a propane. If it is an alkene, then it is a propene. If it is an alkyne, then therefore it is a propyne. And so on. If you have four carbon compound, hydrocarbon that is contains four carbon, that would be butane. If it is an alkene, then therefore it is butene. If it is an alkyne, then therefore it is butyne. For five carbon compound, if you have pentane. If it is an alkene, then that becomes pentene. If it is an alkyne, then that becomes pentyne. And so on and so forth. So you have hexane, hexene, hexyne, heptane, heptene, and heptyne, and so on and so forth. Okay, next. Number the chain to give the lowest number for the first of the two carbons containing the double bond or triple bond. So, number the chain to give the lowest number for the first of the two carbons containing the double bond or triple bond. So, how do we do that? So, for example, in this uh, uh, example of this alkene, so we cannot number this as 1, 2, 3, 4 because that becomes the 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 carbon here would be 3 for alkene, okay? For the double bond that contains the carbon to carbon double bond. So if you're going to number this as this would be our carbon number 1, then that would be carbon number 2, then 3 and 4. So we can attain the lowest number for the two carbons that actually contains either the double bond or the triple bond. So the name would now be 1-butene, so not 3-butene. Okay? If you're going to number this as 1, 2, 3, that becomes 3-butene. But if you're going to number on the opposite, like 1, 2, 3, 4, that becomes 1-butene. And remember the rule, you should give the lowest number for the first two carbons that contains the double bond. So you should number the longest continuous carbon chain in such a way that your first two carbons would actually give the lowest number. Okay, like for example, for pentyne, so you should number the longest continuous as this: 1, 2, 3, 4, and 5. Not the opposite, like 1, 2, 3, 4, because that will give you a name for 4-pentyne, which is actually, that is not the lowest number that you are going to give for the first two carbon that contains the triple bond. Okay, so the number would be 1, 2, 3, 4, 5. That will give you the lowest, which is actually the name is 1-pentyne. Okay. Next. So the third rule is name and number all the groups bonded to the parent alkene or alkyne and place the name and number in front of the name of the parent compound. Remember that with alkenes and alkynes, the double or triple takes precedence over halogen or alkyl group. Okay, so how do we do that? So rule number 1 is if you have a compound, then you first distinguish the longest continuous carbon chain. And remember that in numbering your carbon chain, you will have to number it in such a way that your first two carbons that contains the carbon to carbon double bonds or triple bonds would attain the lowest number. Okay, so in this case, you will number your longest continuous carbon chain as 1, 2, 3, and 4. And of course, not just your carbon to carbon double bond or triple bond would attain the lowest number for that particular carbon, but also your substituent. However, you should prioritize the alkenes or alkynes. That's why remember that with alkenes and alkynes, the double or triple takes precedence over halogen or alkyl group. So that means your priority for numbering the lowest number should be your priority should be from alkenes or alkynes, not on the substituent. Like if you have halogen or alkyl group as your substituent. Okay? So for numbering for this first example, you have 1, 2, 3, 4. That is correct. Okay? So in this manner, you can actually uh, you can actually number your carbon to carbon double bond. You can attain its lowest number and also your substituent. But if you are going to number it on the opposite, like 1, 2, 3, 4. So number 2, yes, your alkane can attain its lowest on the number 2. However, your substituent would be in number 3. So that would not be the lowest number. So like 2 and 3 or 3 and 2. Okay. So you can number this as 1, 2, 3, 4. So in the opposite, so that you will have to attain the lowest number for the carbon to carbon double bond and also the substituent, which is actually a halogen. Okay, so what halogen is this? That is actually chlorine. So therefore, it is found in carbon number 2. So that becomes 2-chloro, 2-butane. Okay, so it has 4 carbon. So that is actually butane, which actually contains a carbon-to-carbon double bond. So this is an alkene. So that is butane. Okay, so 2-chloro, 2-butane. Okay, so our next example. So if you're going to number this, so this is an alkyne, okay? So because it contains a carbon to carbon triple bond. If you're going to number this as 1, 2, 3, 4, 5, 6, your substituent would actually attain the highest or the higher number, okay? However, your triple bond would have an would attain a lower number, that is number 3. But if you are also going to number this on this side, like 1, 2, 3, 4, 5, 6, both of your substituent and also the triple bond would have to attain the lowest number for that. Okay, so you should number this on that way. Okay, so 1, 2, 3, 4, 5, 6. So your carbon number 2 contains a halogen, which is actually bromine. So that is bromo. Then your carbon number 3 contains the triple bond. And the longest continuous carbon chain is 6. So it contains a triple bond. So therefore, this is an alkyne. So the parent is a hexyne. Okay. But your substituent is bromo. So therefore, that becomes 2-bromo, 3-hexyne. Okay, very good. Okay, so the last rule for nomenclature for alkenes would be if alkenes having more than one double bond, they are actually called as alkadienes. So just like our example lately about vitamin A, so it is actually polyunsaturated because it actually contains more than one double bond. So these are actually compounds that are actually called alkadienes for double bonds, for two double bonds, so that is dienes if it contains two double bonds, and if it contains three double bonds, then that is actually a trienes. Okay, so for example, in this compound, so so remember, if you have rule number 1, so you should get or determine the continuous carbon chain. So that becomes 1, 2, 3, 4, 5, 6. And remember to number your carbon chain in such a way that your first two carbon that contains the double bond will actually give the lowest number. So actually you can number this as 1, 2, 3, 4, 5, 6, or the other way around, 1, 2, 3, 4, 5, 6. So it can give the lowest number, which is actually on carbon number 2. and on carbon number 4. So 1, 2, 3, and 4. So that is 2 and 4, or 1, that is 2, 3, and 4. Okay, so that becomes 2, 4. So it is a 6. So you would expect that it is an hexene, but actually it contains two double bonds, so it is actually a diene. So that means that is 2,4 hexadiene. So from the word alka, so that becomes hexa. So if it is a 6 carbon, so you just get the the name, which is hexa, from the root word hexagon, okay, that which contains 6 sides. Then you will actually add dienes. So that becomes hexadiene. Okay, so 2, 4 hexadiene. So another one is this. So you have 1, 2, 3, 4, 5. So you'd expect that this is actually a 5-membered hydrocarbon. So that becomes, if it is an alkane, then that is a pentane. If it is an alkene, so that is actually pentane. But you notice that it is actually a diene because it contains two carbon to carbon double bonds. Okay, so if you're going to number this as 1, 2, 3, and 4, your carbon to carbon double bonds is actually on carbon number 1 and carbon number 4. So the same as 1, 2, 3, and 4, it's actually 1 and 4. So it is 5 carbon, so that becomes 1, 4 pentadiene because it is an alkadiene. Okay? So we have also an example for cyclic or cycloalkane, cycloalkene, okay, that contains two double bonds. Okay? So how do we number this? Okay, so remember that your double bond or triple bond is priority, not your methyl. So you cannot number this as 1, 2, 3, okay? Because this is not your priority. Your priority should be the double bond. However, you cannot number this as 1, 2 because that's not continuous to the double bond. So you should pass the carbon to carbon double bond. If you are going to number this as 1, then this becomes the number 2. Okay? Then that becomes the number 3. If you are going also to number this as 1, this also becomes the number 2. Not this carbon here. That's not number 2. If this is number 1, that is not the number 2. Okay, because that is not actually continuous, or you are not passing the carbon to carbon double bond. So if you're going to number this as 1, then that becomes 2, 3, and 4, 5, and 6. However, you cannot attain the lowest number for for your substituent, and also for uh, of course, you can also get the lowest number for the diene. However, for the substituent, if you are going to number this as 1, 2, 3, 4, 5, 6, that becomes 6. However, if you are going to make this as carbon number 1, then that becomes carbon number 2. Then therefore, your substituent would attain the lowest number, which is on carbon number 3, then 4, and 5, and 6. Okay, so that's how you number. Or this, you can also this make as your carbon number 1, 2, 3, 4, 5, and 6. Or this one, 1, 2, 3, 4, 5, and 6. Okay? So your methyl, which is your substituent, is actually on carbon number 3. And your diene is on 1, 2, 3, and 4. Okay, so that becomes 1 and 4. So you have 3 methyl, 1, 4 cyclohexa, because that is actually a cyclohexane. If it is a cycloalkane, then that is actually a cyclohexane because it contains a 6 carbon. But however, it is an alkadiene, so therefore you would expect that it is cyclohexadiene. Okay, so that is 1,4 cyclohexadiene. So you have 3 methyl, 1,4 cyclohexadiene.